Achieving net zero carbon emissions by 2050 is a daunting challenge, and will require a significant expansion of clean energy sources, including nuclear power. In the short term, the bulk of nuclear new build projects are expected to be light water reactors, the same reactor type that drove the initial nuclear power deployment boom in the 20th century. But other designs under development, including those that use molten salts as both the fuel and the coolant, may play a role as well. In many ways, molten salt reactors, MSRs, are not so different from conventional nuclear power reactors. Like the pressurized and boiling water reactors that have been industry staples since the early days of nuclear power, MSRs leverage controlled fission reactions to produce electricity. But unlike water-cooled reactors, MSR cores are cooled with salts. A design feature which may confer numerous advantages in terms of efficiency and make MSRs especially suitable for non-electric applications. The origins of MSRs can be traced to the Oak Ridge National Laboratory, ORNL, in the United States. Initially developed as part of the aircraft reactor experiment in the 1950s. ORNL then ran a trial known as the Molten Salt Reactor Experiment, MSRE, from 1965 to 1969, operating an experimental 7.34 MW (th) MSR. The project established proof of concept for reactors powered by liquid fuel and cooled by molten salts. While MSRs were first conceived of and tested several decades ago, this reactor type has yet to see commercial deployment, though this may change in the near future, said Tajana Jevramovic, the acting head of the IAEA's Nuclear Power Technology Development Section. Molten salt coolants have exceptional capacity for heat absorption, which could allow MSRs to operate at the very high temperatures needed to produce high-grade heat to drive industrial processes including hydrogen production. MSRs may use molten salts as a coolant and/or fuel. Most designs are based around liquid fuels dissolved in the molten salt-based coolant. Others are powered by the more traditional solid fuel rods, with the molten salts only serving as the coolant. A new publication in the IAEA's Technical Report Series, Status of Molten Salt Reactor Technology, outlines the current status of MSR technology around the world. It reviews the history of MSRs and takes a look at the current research and development activities taking place. The advantages of this technology, including a smaller high-level waste footprint and passive safety features, as well as some of the technical challenges, such as developing components capable of operating in very high-temperature environments, are detailed. Once sufficient experience will be collected, MSRs have the potential to be the most economical reactor type for closed fuel cycle operation, said Jiri Kreppel, a senior scientist in the Advanced Nuclear Systems Group at the Paul Scherrer Institute and chair of the MSR Working Group in the Generation IV International Forum. Several designs, utilizing thorium-232 and uranium-238, could provide an unprecedented combination of safety and fuel cycle sustainability. MSR designs under development. Several MSR designs are currently under development and approaching deployment readiness. In Canada, a molten salt-based small modular reactor (SMR) concept passed a crucial pre-licensing vendor design review in 2023, the first such review completed for an MSR. And other projects, including in China and the US, continue to make progress, with the hope that MSRs could begin to see deployment as soon as the mid-2030s. MSRs can help improve the sustainability of nuclear power, including by contributing to the minimization of nuclear waste and enhance proliferation resistance, said Kailash Agarwal, an IAEA fuel cycle facilities specialist. MSRs, particularly those powered by fuel composed of U-233 and thorium salts, can also assist in conserving natural uranium resources. While optimism abounds for deployments in the relatively near future, key challenges remain to be addressed. Standards in design safety and fuel salt transportation have yet to be developed, and supply chains for MSR-specific reactor components do not yet exist. Analyses of potential accident scenarios unique to MSRs also remain to be conducted. We know that MSRs are a viable option to support nuclear power expansion plans, but there is still much work to be done before commercial deployment, said Jevramovich. Licensing new reactor technologies requires a lot of thorough evaluation, particularly with regard to safety analysis. It's also important for interested countries to consider the specific role they envision MSRs playing in their energy systems.